This presentation will address the so-called normal distribution, a central mathematical idea in statistics. What is a distribution? In statistics, a distribution is a way of describing how random events occur. Even though we cannot tell the exact outcome, we will use the distribution to describe which results are more likely or less likely. The histograms here demonstrate the different ways that the data can be distributed or spread out. But many data may follow a bell curve, with most observations take values in the middle range and rare extreme events at the two tails. This bell curve is a normal distribution. The normal distribution is probably one of the most widely known and used of all statistical distributions. It has many desirable properties and approximates many natural phenomena very well. Some examples of normally distributed variables include, but not limited to, height, blood pressure, test scores, size of things produced by machines, and measurement errors. There are an uncountable number of normal distributions out there. They all follow some kind of bell curves. All of the normal distributions have the following properties. First, the highest point of the bell curve is the mean, median, and also the mode of the distribution. That means the normal distributions are unimodal. Second, we use the total area under the curve to represent the total probability of the normal distribution. The total area under the curve is 1 or 100%. Third, the bell curve or normal distribution is completely symmetric about the center. In other words, it's a mirror image to the left and to the right of the center, or the mean. Lastly, using the symmetry of the bell curve about the center and the total area under the curve is 100%, we know that 50% of the values are less than the mean and 50% greater than the mean. Another important property of the normal distribution is that any normal distribution can be fully characterized by its mean and its standard deviation. To describe the shape of the bell curve for a normal distribution, all we need is to specify its mean and its standard deviation. The first graph demonstrates three normal distributions with similar shape but except different centers. The means for those normal distributions are -10, 0, +25 respectively. The second graph shows that even though the two bell curves have the same mean, they could be quite different in terms of the spread of the distribution. The bell curve with a taller middle region is less spread out compared to the second bell curve. It is not surprising that the first curve has a smaller standard deviation compared to the second one. To specify a particular normal distribution, we usually write this way. X here refers to the variable of interest we are analyzing. It could be some machine measurements or annual salaries. The squiggle sign means follows certain distribution. N stands for normal. Here are some normal distributions. The first normal distribution has a mean 5.2 and STD of 1.3. The second one is a normal distribution with mean 0 and a standard deviation 1. The third one is a normal distribution with a negative mean. And the last one is not a valid normal distribution because standard deviation cannot be negative. Because there are infinite number of normal distributions with different means and standard deviations, a normal distribution with mean 0 and a standard deviation 1 is usually used as a reference distribution to compare different normal distributions. It is known as the standard normal distribution and is usually called the Z distribution.